It's 2 a.m., production is down, you are staring at a 50,000 lines of logs trying to find just one line that caused the production outage. I have seen this pattern across the different domains. Logs have the answers, but under pressure, finding it fast is the key. Today I am going to show you how to build an AI-powered log analyzer that reads your log files, sends the important part of your logs to OpenAI, and generates a clean incident-style report stating the likely root cause and the recommended fix. So let's jump right into it. I have fed the tool with a sample application log files containing all the information, warning and errors. The script will filter out the noise and only sends the important lines to OpenAI, which ultimately returned the report, a structured report stating the root cause and the actions to be taken. This is the sample raw log file I have used. Pretty straightforward with some info, warn and error messages and the stack trace. A classic enterprise debugging situation. One issue occurs and it leads to a chain reaction of other issues. Till the log files are small, it's easier to manage, but once it grows, it becomes really painful very quickly. The architecture is intentionally kept very simple. First, we read a log file from the disk. Second, our Python code will filter the log lines from that log file. Third, those filtered logs will be sent to the OpenAI with a structured prompt. And fourth, the generation of the analysis report. The project has got only a few files. First is the logparser.py, that is the main file for this application that does the magic. Then we have the sample application log file. Then we have the .env file which holds the environment variables used for this application. And then we have the requirements.txt file. Here we are just using two packages for this application. One is the OpenAI, that is the official OpenAI client for the Python. And then we have the python.net which is used to load the environment variables used in this application. Before starting the code, let's talk about the .env file. So I created a copy of my .env file and named it as .env.example, and I am using three environment variables here. One is the OpenAI API key, then the OpenAI base URL and the model that I am using. So here you need to replace this API key with your own OpenAI API key. How to create that API key? I will put the link in the description. Base URL can remain same, and then model also you can keep it same or change it if you want. One thing to note here is never ever check in your .env file to any public GitHub repo. As you can see here, I have added my .env file to my .gitignore file so that by mistake also I don't check it in, because there are bots scanning those public GitHub repositories for any exposed API keys. And believe me, if by mistake you check it in, it can cost you a fortune very quickly. Let's jump into the main file of our application, that is the logparser.py. At the top, we have few standard import statements. First is the argparse that provides the clean command line interface for our application. Second is the OS that helps us to load the environment variables. And then we have the sys, which provides a clean exit for our application if something goes wrong. Then we have the OpenAI package, which is used to interact with the OpenAI API, and the .env which helps us to load the environment variable. So this is the method which loads the environment variable defined in the .env file into our application. And here we are reading the model that is defined in the .env file and storing it in the default model variable. We also defined a variable with the log levels that we care about in our application. Create OpenAI client is the function that creates the client for us to interact with the OpenAI. First thing it does is it reads the OpenAI key and the base URL from the .env file. If the key is not present, it will print that explicitly in the logs and then exit from here. Next is the read log file function. We are using the with open pattern. What it does is it will first open the file and then closes it automatically once the file is read. If there are any exceptions in reading the file, then again we are printing that in the log and then exiting it. And then we have the filter logs function, and this is the most important local logic in this application. So in the real systems, there are a lot of informational log lines. Informational log lines we need, but for any incident, we usually care about any critical messages, errors or warnings. So what this function does is it will split the log lines and only pick the log lines that have the important log levels that we defined previously. But there is one extra detail, stack trace. So stack trace usually does not start with the word error, but it starts with @ So what we are doing here is we are using a while loop, and then we are looking ahead and taking all the lines that are part of that error message. So that way we don't miss out any of the important details about that error. And finally, it joins all the filtered lines and create one single string. And now we are building the prompt. This part is very important. We are not just asking what is wrong with these logs. We are asking for a specific report format with summary, critical issues, warnings, root cause, and the recommended fix. A better structured prompt usually means a structured output as well. And here we are saying the system role to take is the expert DevOps engineer and a log analyst, and then returning the message content from the response. We also specify the max tokens as 1024. This helps us to keep the response short as well as helps us to minimize the cost as well. Next, we have the parse argument method. This method makes our script a little flexible. So we have the log file parameter here. It is an optional parameter. If you can pass it any log file path name. If not, it will just pick the app.log file, which is part of the application. And the second argument is the model. This picks up the model that is defined in the .env file. So this helps us not to change the script every time we change the model. Now we have the main method which connects everything together. So first thing it does is it reads the arguments, it reads the log file, and then filter the log statements from within the log files, and those filters log statements are then sent to the OpenAPI for the analysis. The OpenAPI will analyze those log statements and then sends the analysis report, and at the end we print that analysis in the terminal. And this is the last block. It is the standard Python practice. What this means is the script can be run if executed directly, and at the same time, of course, it can be imported in some other files and it still can be run safely. So now let's run it one more time. So this tool reads the log file, filter out the relevant lines of logs, and then creates a report out of it with the help of OpenAI. So this is a small project, but the pattern is powerful. Take messy operational data, filter it, structure it, sends the main context to the OpenAI, and then gets back something that a human can act upon. That pattern can be applied to various workflows. It could be reading the log files, it could be incident reports, it could be financial data, it could be your health report. It works for all. That being said, there are many ways to further improve it. In the next video, probably we can create some kind of UI on top of it to make it more user friendly. So this was the AI powered log analyzer tool built with the help of Python and OpenAPI. If you are interested in practical AI engineering, automation, real-time applications, this channel is for you. I am Manoj Matpal and this is Matpal Tech. See you in the next video.